Hello SL2. Tonight's topic is 8.3 and it's probability. Many of the topics that you learned last year in SL1. Just to get an idea, these are all the topics I'm going to be talking about tonight. And I recommend that you go ahead and click on this link and bring up the slides so that you can just write in some notes or write on there. So you'll have less writing tonight. So go ahead and stop the video and print that out, and so that you can have less writing tonight. Okay, so the first couple of things is some definitions, remembering the basics with probability. And first I want you to think about theoretical probability, what that means. And that's the measure of the chance of that event occurring in any trial of the experiment. And the notation that we use for a probability of event occurring is P parentheses E. And whenever you see that, they want to know what do we expect to mathematically happen. The difference with theoretical is just that, and experimental is experimental probability. You're going to actually have data, relative frequency, and you'll have the number of events that occur out of the total numbers of trials of an experiment. And our probability will need to be some number in between 0% and 100% if we're looking at the percent data. If we're looking at in a decimal range, it'll be some number between 0 and 1. We can't have a probability bigger than 1 or more than 100%. You can have complementary events, and if E is an event, then E prime, this notation is important to realize, is the complementary event of E, such that the probability of E and the probability of the complementary event is going to equal 1. Or a lot of times you'll be asked to find the probability of an event or the complementary, and you'll be subtracting that from one to get the other. And a good example of this is when we think about rolling a die. If E is our event of rolling a 6, the chances of rolling a 6 when I push this button here would be, well, if you think about that for a second, the chance of rolling 6 is 1 over 6. We have 1/6 of a chance that we'll get a 6 because of possible numbers, outcomes. There's 6 different, and we're only going to get one try. So the probability of not rolling a 6 would be 1 minus 1 over 6. Which would be 5/6. So there's a 5/6 chance that when I push this, we won't get a 6. The interesting thing is we don't know until we push it, so let's go ahead and try.
1.
And we got a 1. So we that was most likely event that we would get a complementary event, that we would not get a 6.
4.
And then we could try this. Feel free to roll some die in the, or dice in this unit if you want to get some out. We'll be using this some more. The first thing we're also going to be talking about is just sample space and set of all possible outcomes. And there's 3 ways to list our sample space. We can use a list, we can use a TD chart, and we can do a tree diagram. So our first example, we're going to put in this first, the same one across here. We'll be talking about the possible outcomes of tossing 2 coins. So there's 2 possible. If I then pull a coin out of my hand, my wallet, and roll and toss it in the air, we could only possibly get heads or tails. So we can list out the possible options of heads and tails. We can say that on the first try, let's say I roll a heads, and then the second time I toss the coin, I get a heads again. So one option is heads and heads. Another option would be heads and then I get tails. Another option would be tails and then heads. And lastly, I could get 2 tails. So those are my possible 4 different outcomes for tossing 2 coins. The 2D chart you may not have seen before. And what that is just a way to show all the possible outcomes. And you just list on one side the possible outcomes and on the other for the 2 items that you're thinking about. So, and then you would put dots on the options. So we know there could be a heads. We know there could be heads, tails. We know there could be tails, heads. And lastly, tails, tails. So that is another way to represent this, and it's called a 2D chart. You probably have seen a tree diagram before, and in a tree diagram you list your options for your first item. So we could have a heads or we could have tails, and then you show the possible outcomes from there. So after heads you could have tails or you could have heads again. After tails, you could have heads or you could have tails. So here is our how we represent a tree diagram. Alright, for the second example, I want you to go ahead and change this a little bit because this will make it really long. And I just want you to try to list your sample space of tossing a coin and rolling a die simultaneously. So I want you to do all the list, the 2D chart, and the tree diagram, and then bring it back. So this time, instead of 2 die, which would be kind of big, a lot of things, I want you to think about just a coin and rolling a die simultaneously. Okay, so you should have gotten 12 possible outcomes and been filled in your dots here for all 12 possible outcomes. The 2D chart is helpful if you have something that says you would not get a 2 at all. It's helpful to see that in this visual. And then the tree diagram we're going to be looking at with probability here in this next example. But hopefully yours match. Okay, so on the next example, we'll be using a tree diagram to help us determine the probability. So the first thing I want you to do is go ahead and read through this problem, and then we're going to be talking about it. Alright, so we have a student at an IB World College, and the probability that he is woken by his alarm clock is 7/8 of the time. If he is woken by the alarm clock, then the probability that he's late for school is still 1/4. If he is not woken by his alarm clock, then the probability he'll be late for school is 3/5 of the time. So it definitely goes up. He'll be late, more likely to be late if his alarm clock doesn't go off. So W is the event that he is woken by his alarm clock, and L is the event that he's late for school. So we're going to just see how this tree diagram is set up and make sure we've worked through the different probabilities as we're setting it up. So the first part is W is woken by his alarm clock. So they give us that's a given. He's woken by his alarm clock and it's 7/8. That's the probability that he is woken by his alarm clock. Now remember what the W prime would mean, and that would be the complementary event. So the fact that he is not woken by his alarm clock would be 1 minus our probability of W. So 1 minus 7/8 would be equal to 1/8. So that would be the probability that he's not woken by the alarm clock. Okay. Now L is he's late for school. So the probability that he's woken by his alarm clock and he's late for school they give us is 1/4 of the time. And we can uncover the other option where he's woken by his alarm clock but not late for school. And again, that'd be 1 minus 1/4, so that would be 3/4. The other option here is if he is not woken by his alarm clock, then the probability he will be late for school is 3/5 of the time. So if he's not woken by his alarm clock, then he'll be late, will be 3/5 of the time. So if he is the opposite of that, the complementary of late for school, if he's not woken by his alarm clock, would be 1 minus 3/5, so that would be 2/5. Okay, so our first part was just copying and completing the tree diagram. Now we have one question, and there could be several questions in one like this, but we just have one for now, and that is, what is the probability that the alarm clock went off and he is late? So that would be where here is when he is woken by the alarm clock and he is late for school, and we would multiply those two probabilities. So we have 7/8 times 1/4, and that would be 7/32. That's the probability that the alarm went off and he's still late. So not likely, but but still possible. Okay, so a couple more definitions. The first is intersections, and when you have two sample spaces, they can overlap, and we're going to be multiplying when they overlap. So in this case, if I have an example that I have students have high GPA, and they would be in this circle, plus the other sample space where they play sports, then the intersection of them would be this middle part where they have a high GPA and they play sports. The union would include everything. So for a union, we would have all of this section. So in this case, you would be adding when you have a union. Let's see how this works. So our first example here, we're rolling 2 dice twice in a row, and we want to know what the probability of rolling a 6 and then a 12. So our possible options for adding up to 6 when we roll 2 dice would be 5 and 1, 1 and 5, 4 and 2, 2 and 4, and 3 and 3. So out of all the possibilities of throwing 2 dice and getting 6, there's 5 options, and out of a total of 36. The probability of getting 12, and the only way you can get 12 with 2 dice is 6 and 6. There's only one option out of 36. So in these cases, these are independent, and they'll be intersections. So here we would multiply and the two probabilities and get 5 over 1,296. Our next example, we have a probability of a heart being pulled from a deck, then a spade without replacing. So you have 13 over 52, and then spade would be 13 over 51 because we wouldn't replace that heart. And these are dependent and intersecting, so we still would multiply. When you multiply them, you get 169 over 2,652, which would then simplify. Our last problem here, I want you to go ahead and try. Okay, we'll be trying these in class.